Hey Tech Geeks, welcome back to Tech Geek Life. And today we are going to learn about one of the most important concepts in C++, object-oriented programming or OOPs. Understanding OOPs will not only make you a better C++ programmer, but it will also help you write more structured and reusable code. Let's jump in. So what exactly is OOP? Object-oriented programming is a way of organizing your code by using classes and objects. These objects represent real-world things like cars, books, or even users in a system. OOPs helps you structure your code in a way that models the real world more naturally. Why do we use OOPs in C++? Well, it helps us make our code reusable and modular. With OOPs, we can break down complex problems into smaller manageable pieces, and when your code is easier to maintain and debug, life as a programmer becomes so much simpler. Now, there are four main concepts or pillars of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. These pillars are the foundation of OOPs and are what makes it so powerful. Let's break them down one by one. First up is encapsulation. This is the concept of bundling data and the methods that operate on that data within a single unit called as class. By using access specifiers like private and protected, we can control how the data is accessed from outside the class. Next is abstraction. Abstraction allows us to hide the complex implementation details and only show the users what's necessary. For example, when you are using a phone, you don't need to know how all the internal circuit works, right? You just need to know how to make a call. Then we have inheritance, which allows one class to inherit properties and methods from another class. This is great because it promotes code reuse and allows you to build on existing code without rewriting it from scratch. Finally, there's polymorphism. Polymorphism allows one function or object to behave differently in different contexts. For example, a single function can perform different tasks depending on the type of input. This is super useful for flexibility in your code. In C++, a class is like a blueprint, and objects are instances of that class. You can think of class as a recipe and objects as the actual dish you make from that recipe. Here's an example of a class definition in C++. We have a car class with attributes like brand and year and a method called drive. This is a simple way to model a car in code. Once you have a class, you can create objects from it. In this example, we create a myCar object from car class, assign values to its attributes, and call the drive method. Constructors are special functions that are automatically called when an object is created. They are used to initialize the object with values. Here's how you define a constructor in C++. In this car class, the constructor takes two parameters, brand and year, and initializes the object with these values when it's created. In this example, we can see how inheritance works. We have an electric car class that inherits from the car class. The child class, electric car, gets all the features of car and also has its own unique properties like battery life and a charge method. To wrap things up, we have learned about the four main principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. These are the key concepts that make OOPs such a powerful programming paradigm. That's it for today's video. In the next one, we'll dive even deeper into OOPs with more advanced topics like virtual functions and polymorphism in action. If you found this video helpful, make sure to like, subscribe, and hit the bell icon so you never miss out on Tech Geek Life content. Thanks for watching and a happy coding.